This episode is sponsored by DigitalOcean. DigitalOcean is the hosting provider I use for devchat.tv. I also use it for my applications that manage the RSS feeds, scheduling, and sponsorships involved in delivering these shows. DigitalOcean is easy to use, has data centers all over the world, and provides terrific services including server hosting and object storage for delivering your web applications and assets quickly and easily. I use DigitalOcean because I love their interface. I get SSD storage for my servers, and their support replies quickly. So go check them out at digitalocean.com.
So hi, I'm Greg Wilson, and today we're here to interview GigaChuck. Chuck, how's it going?
It's going all right.
So what are you here to talk about today?
We're here to talk about you.
Oh, turn the tables on me then. Okay.
Yeah, absolutely. So just to kind of get the ball rolling here a little bit, now, you've been on a few episodes of Ruby Rogues and JavaScript Jabber. I think mostly Ruby Rogues. You were on episode 184.
I think it was just one episode of Ruby Rogues. I think I introduced some other people to you.
Well, we've got you on episode 184, what we actually know about software development, why we believe it's true. And we had you and Andreas Stefik.
That was just Andreas. I was the one who introduced you folks to him.
Oh, I thought you were on those too.
If I was just applauding in the background every time he got snarky.
Okay. Well, I have you listed as a guest there, so.
There you go. There you go. If you got a choice of listening to him or listening to me, you listen to him, right? He does the work. What's the line from Winter Soldier? I do what he does, just slower.
Yeah. No, we have you in here with an introduction and everything, so you must have been there.
There you go.
And then we also had you on and we talked about what's missing. And that was back in 2016. We had you on twice.
Yeah, there you go. Well, I hope I don't repeat myself too much today.
Yeah, well, it's interesting to talk about this, the topics that we talked about with you, which is generally, okay, what do we actually know? Like, why do we believe this works? Do we have any actual data that back up what we're saying? And
well, okay, here's some data. Here's an interesting recent result I'd like to share. So Christian Bird is a researcher at Microsoft, and they did an interesting study that was published last year. Suppose you take a bunch of JavaScript programs off GitHub where people have found and fixed bugs, and you go back to the version that includes the bug, and you say, what if we had strong typing? What if we had TypeScript? Okay. How many of these bugs would have been caught before the code could even run? So I think this is a really balanced way to measure the effectiveness of strong typing, because I don't get to pick the bugs. I don't get to make up the cases. I'm saying, given your code, it turns out 15% of bugs in real JavaScript programs just would not happen if we had TypeScript style typing. Okay.
Wow.
Now that's 1 in 7. Now, we don't know, are those the hard bugs? Or are those, oops, I made a typo and it'll get fixed anyway.
Right.
If you pull up the paper, and I'll send you a link and you can include it for folks, you can do a bit of digging into how much effort did this require. We don't know, because you can't measure by looking at GitHub repositories how many hours somebody spent scratching their head. You can take a look at how big was the fix that actually corrected the bug, but the programmers will often fix a bunch of things at one time, and then you get one massive pull request. So getting a handle on whether those 15% are the easy bugs or the hard bugs, can't say, but 15% is 15%.
Yeah.
That's taxes here in Ontario. That's the equivalent of telling me I don't have to pay. I'm serious.
Yeah.
15% people will say, well, that doesn't sound like very much. That's what I pay in sales tax in the province of Ontario. If somebody told me my business could run without provincial and federal sales taxes, I would say, thank you very much. When are they going to arrest me? Right?
Yep.
So that's the kind of result that I think is fascinating. And if you want to dig deeper, there's a guy in the UK named Derek Jones who is putting together a book called Empirical Software Engineering Using R. And what he's doing is going back to people who've written papers like that and saying, can I please have your data set? I want to go and redo some statistical analyses so that I can teach people how to analyze this kind of data.
Right.
And, just yesterday, he had a blog post where he's looking at how many times do you take the true branch rather than the false branch? And how many times do you exit early from functions? And what can we infer about the quality of your testing by looking at the paths through your code? And it turns out we can learn a lot about how well you're testing by looking at how often you took an else branch and then immediately exited, which is a pretty clear sign of, oh, file failed to open, let me get out of here.
Right.
So there's patterns like that. And when I look at this stuff, what I see is the future of software engineering. Right? Okay. I was taught, your listeners won't be able to see it, but I'm holding up my pinky finger. That's an iron ring. You get that when you get an engineering degree in Canada. Right. And the story behind it is there was a bridge that collapsed back in 1901, and they started making rings from the metal and putting them on engineers to remind us what happens when we drop a zero, right? When we drop a decimal place. Okay. Now, we wear our mistakes on our hands forever. Mm-hmm. And I was taught that engineering is what you get when you take the scientific method and you apply it not to understanding the world as it is, but to designing better things.
Right. Okay.
And what Derek and Chris and Danae Ford and dozens of other people are now doing is saying we can do that with the data that we finally now have about software projects. And I want everybody who does a degree in computer science to spend at least one course getting and analyzing data so that they know that this is normal. Right. They should just instinctively do the kind of forecasting that anybody who's done an accounting course will do with profit and loss. I should be able to look at the rate at which bugs are coming into a project and draw a straight line through them and say, given past experience, that means we're 5 months out from release. That's a really simple calculation. If I'm finding 6 bugs a day, last time we were in that state, we were 5 months out from release. Okay. The analysis is trivial. You can do it in a spreadsheet or you can automate it. And yet most programmers don't think that way. And yet we're telling everybody else to go and do analytics on their websites, right? Yeah. We're telling all of our customers to go and get data and analyze it. We're not turning that lens on ourselves. And people like Derek are showing us that we can do it. And in part it's possible because places like GitHub and Stack Overflow make all of this information available. We finally got the raw material that is worth different stats, right? So how does this relate back to JavaScript? Increasingly, I believe that JavaScript is the one unavoidable language.
It's looking that way, yeah.
It's just wherever you are, it's like Donald Knuth was asked why he wrote the first version of Tech in Pascal, and he said it was everybody's second favorite language.
That's so true.
But it's the one, if you know anything, you can understand Pascal, you can work with it. It's not your first choice for number crunching or for writing an operating system, but it's a good multi-purpose tool. And these days, because it's got a lock on front-end stuff, I wouldn't have said this 14 months ago, but having spent 6 months last year learning modern JavaScript while working for a company called Rangle here in Toronto, ES6 is a nice language. It's got some warts. It's got a lot of warts inherited from earlier versions. Right. And the ecosystem makes the Holy Roman Empire look well designed, but but what it's really got going for it is, 1 million bright people all around the world hammering on it. And that's pretty powerful. And I will bet money, I'll bet you the contents of my wallet, that 10 years from now, most of the people doing data analysis will be doing it in JavaScript. I think the Python in our communities are going to keep growing, but I think that as more and more new people pile in and they want to do some simple calculations, JavaScript, by which I really mean Node on the back end and, pick your favorite technology on the front end, it's got your visualization, it's got your database interface, it's got everything you need except the statistical libraries. And if I've got a choice as somebody who's building websites between learning a new language to get their statistical tools when all I really want is a simple linear regression, or somebody's going to build me a package in JavaScript that will do linear regression, and now I've got all of Node to go with it, I know which way I'm going to bet, right? And y'all are too young to remember this, but we went through something similar once before. Back in the 1980s, when I first got into supercomputing, everything was custom hardware. People like Cray and Fujitsu and Thinking Machines and Mako, they were all building these specialized machines with their own processors and their own buses and their own storage. And meanwhile, over there, Intel is making chips for PCs and we're laughing at them. What we didn't realize was that for every dollar people were putting into supercomputing, they were putting $500 or $5,000 into desktop computing, which meant that all the smart people were over there making that dumb thing go fast.
Right.
And the same thing has happened with JavaScript, right? That, we're laughing at it because there's so much to laugh at. But man, there are a lot of smart people who have been working really, really hard to make this go fast and to build libraries and the tooling around JavaScript, VS Code and JavaScript.
Yep.
There's a nice environment. And the only thing that's missing right now is that high performance matrix library that will let us do the number crunching. But if I have to choose between, 3 guys get together one summer and build that, or the Python or the R people build all this other stuff, all these visualization libraries and all these database connector libraries and this and that and UI frameworks and all of this stuff, I know which way I'm going to bet. And I hate myself for saying it because I'm a Python guy. Right?
Yeah.
But if any of your listeners want to be rich, famous, and popular, I'm quite serious about this. At its core, the numerical Python libraries are a bunch of C functions that are wrapped up to give them a Python interface. Right? That gives you, basically, it gives you linear algebra. You could take those same libraries and rewrap them to be callable from Node.
Yep.
Now, you still wouldn't have the nice array syntax where, low colon high selects a slice out of an array and so forth. But what you'd have is someplace to start with.
Right.
And, WebAssembly means that 12 months from now, anything you build, you'll be able to move over into the browser at pretty much the same performance.
Right.
That looks attractive. You've already got people using D3 and Vega and other libraries to do Viz in the browser, right? All of these pieces coming together. The one thing that's missing is somebody to wrap up those C libraries. And if I was a young man with time on my hands, I think it would be fascinating to see what happens when you bring high-performance numerical computation to a community that thinks delayed computation is normal. The biggest thing I learned working at Rangle and learning modern JavaScript last year was everything's a callback or a promise or it's a sync away, but everything is, I'm going to want this later. And all the libraries you're working with are built around that notion of delayed computation. So programmers who are working with them, it's a hard concept to wrap your head around. It's a serious impediment to people who just want to write a little bit of code. But once you've got your head around it, once you get used to the idea that everything happens later, what do you do if you're working with enormous data sets and it's going to take seconds or tens of seconds to process them, and maybe the processing is over there on the GPU or out there on the cluster, but that doesn't feel weird to you because you're used to things being, start the computation and tell me when you're done, and here's the next step, right? So it's almost as if we're reinventing continuation passing style from 20, 30 years ago in JavaScript. And then, I don't know what that does to the design of the libraries. I don't know how I would redesign fast numerical computations if I could take advantage of that idea. So somebody's going to build this, right?
Yep.
And they're going to have 100,000 users by the end of the year.
Yep.
So.
All right. Well, I'm going to change the topic a little bit because this is an interview about you and your history. I really want to do an episode on JavaScript Jabber or Ruby Rogues and talk a little bit more about this. So we'll get that set up. I'm sure people are sitting here listening, fascinated, and they're like, "What? You're going to change the topic on? Don't know." But anyway, I find that the people are as interesting a lot of times as the technology, and so I set up this show to kind of capture that for people and say, "Oh, okay, you've heard Greg on the podcast. Here's where he came from. Here's his background. Here's what he learned. Here's how he learned it." and things like that. I also just wanted to quickly shout out about Rangle. You've mentioned them a few times. They're a terrific company, and they've sponsored these shows. I've talked to their folks at the conferences. We've had several of their folks on the shows. So yeah, great folks.
There are a lot of companies that make a lot of noise about diversity, about being more inclusive, and Rangle is actually doing something about it. I don't know if you've interviewed Emily Porta from the Bridge program. Okay, so there's a lot of sort of intensive coding boot camps out there, 2 and 3 month programs. Unfortunately, it's still very difficult for their graduates to get good jobs.
Yep.
And you can talk about snobbery in the industry or about the fact that you just can't cram enough into a 3 month program to get people where they need to be to get rolling. So Emily and others at Rangle set up a program called Bridge, which is 2 nights a week for 12 weeks, pretty intensive, but here's the next couple of steps to help you get going. And it's aimed at women trying to get into the tech industry, women who've gone through these boot camps, and this is their next step so they can land that first real dev job. And Rangle has put a lot of resources behind that. People like Abdella and Purvi, Lindsay Canton, a lot of others, they've been given time and resources to do this. And in some very long view, Wrangle's going to get a couple of hires out of it. That's great, but that's not why they're doing it. They're doing it because it's the right thing to do. And you won't find a lot of companies in the tech sector that just roll up their sleeves and do something about the god-awful imbalances in our industry. So, full points to Rangle.
Yep. I'd like to set up a time to talk to her as well. So
happy to do the introduction.
Awesome. All right. Well, let's dig into Greg. Talk about where you come from, what your experience is. We usually start right at the beginning. So how did you get into programming?
I arrived at Queen's University in Kingston, Ontario in September of 1980, thinking I was going to be a chemistry major. And 6 weeks of university chemistry was enough to convince me I was going to be something else. I come from a very small town on Vancouver Island. I was, I think, the only boy from my high school graduating class who went directly on to higher education. There were 2 girls and myself that went on to college. Everybody else, you finish school on Friday, you graduate on Saturday, you sleep off the hangover on Sunday, and Monday morning you start at the mill at $18.50 an hour.
Right.
And so I'd seen computers. I think I'd even, typed in a Hello World program in BASIC on a computer at a school fair at some point. But September of 1980, I was the last generation to use punch cards on an old Burroughs computer in the first year programming course at Queen's University. And it did nothing for me. There was no aha moment.
Right.
But a few months later, I got to do another course where we were actually using terminals. And for some reason, whether it was the immediacy of the feedback or maybe I'd matured a little bit, which is unlikely, people will tell you that still hasn't happened. You put all this together, and it was like, oh, this is interesting. And it really was a toss-up between computing and physics. So in the end, I wound up doing an engineering degree, which was the worst of both worlds. But by the time I graduated, I knew that what I really enjoyed was building software, and people were willing to pay for me to do that. I got hired to do math with computers, and in that first job, I didn't do any of the math. I just helped build the software. And then I got a second job where there was no math at all. It was the summer of 1985, and I was working for a lab in Ottawa, and we were building what I believe was the world's first wireless mouse. We took apart a U.S. Navy pilot's helmet and got the Polhemus sensor out of it that gave us XYZ and 3 degrees of rotation, and stuck that in a handheld thing that looked about like a cattle prod. It wasn't a small device. And we had a Mac with a 3-digit serial number because the very first Macs had come out, and hooked the whole thing up to a plasma projector. And we built this lovely system where you could actually stand there and point at the screen and the cursor would kind of track you. And this was black magic. This was witchcraft. And Bell looked at it and said, yeah, we don't think there's a market for this. It was a beautiful product. It gave great demos, but a lot of my stories aren't true. This is a true story. We had one manager, we had to do demos every week because people thought this was a cool toy. And we had one manager who was coming in, and whenever he was there, the mouse would just zing all over the screen. And, we can't figure this out. And he eventually tells us he's got one of those old style pacemakers. He's basically a radio station in the room with us.
Oh, geez.
Right. And he'd known this. He just thought it was, he's just thinking, let's see how long it takes these young punks to figure out what's actually going on.
Right.
So there's 2 weeks of my life thinking I'm going to have to digitize an entire room in 3D at 10 centimeter intervals to build a correction table. And in the end, it turns out it's one guy with a pacemaker. So there you go.
That's awesome.
Went from there to do a master's degree in artificial intelligence at the University of Edinburgh, mostly because I'd never lived outside Canada and I wanted to see a bit of the world. And AI was a hot topic in the mid-'80s. A year of AI was enough to convince me that I wanted to be doing something else, because back then, everybody was dogpiling in AI. The Japanese fifth generation project was running. DARPA was pumping money in. It didn't matter what you were doing. You called it artificial intelligence because then people would throw money at you. And
there's a little of that going on today.
Oh, if you're looking at machine learning and data science these days, believe me, it feels familiar. Right? I don't care what you're doing. Call it machine learning, and away we go. And so at the end of the year, I decided I wanted to stay in Scotland a little while longer. The physics department was looking for a programmer to help work on the supercomputers that they had just bought. And I wound up staying for 6 years and got a PhD along the way. And wandered the world for a couple of years doing odd jobs here and there, mostly academic, and eventually wound up in Toronto. Moved here in 1994 thinking I'd be here a year or two, and it has been 24 years. It's amazing what a mortgage will do to your mobility.
Yep. So I'm curious. We had you on Ruby Rogues. Do you have a lot of experience with Ruby?
Nope, none at all.
Okay.
I'm a Python user, but increasingly I am of the opinion, jokes aside, that whenever you hear somebody making a snarky remark about a language, you ought to say, well, that's interesting. Show me your data set.
Yeah.
Right? If I'm going to compare the performance of two cars, or if I'm going to compare the efficacy of two medications for high blood pressure, right? If I say, my grandma thinks this works well, you're entitled to think of me as a crank. And some of this, I think, comes from the fact that I've spent a lot of time over the last 10 years, but particularly over the last 8 years, teaching scientists how to program. And some of the science has rubbed off on me.
Yeah.
Right. There's this idea in science and, in other fields, marketing, for example. We don't think of marketing as a science, but these days, if you want to be taken seriously, you've got to be doing some analytics. You don't run a multi-million-dollar campaign because your gut tells you.
Right.
You run a multi-million-dollar campaign because you've gone and you've done some measurement and you've got some data, and you still have to apply a lot of guesswork, but at least you've ruled out things that are obviously false. And, by that standard, it's not just tedious to listen to debates over Python versus R versus Ruby versus JavaScript versus whatever the coming down the pipe next. It's embarrassing.
Yeah. It's interesting you bring this up. I mean, these are sort of the political debates that we have in the arena of code. But I mean, a lot of other areas you could make the same claims in. You hear a claim from a politician. You hear a claim on the news. You hear a claim. I mean, one of the ones that I've seen spread around the programming community that's not so politically charged is, the violence in video games causes people to go and do bad things. And again, it's like, where's the data? Is it a problem? Is it not a problem? Do we actually know where this comes in? And
so it's funny you bring that one up. The answer isn't clear, because if you're asking, does it affect people in general? It's a very different question from, does it affect males aged 15 to 25 from particular socioeconomic backgrounds, right? And as with studies that were done of the relationship between smoking and cancer from the 50s through to the 70s, you can design your study to get the answer that you want without actually breaking any of the rules. And, it's ironic that a company like, pick one of the big games manufacturers. What's the Electronic Arts?
Right.
What do you think their advertising budget is every year? $100 million on ads?
Easily.
Easily. Okay. So they're spending that money because they believe that putting images in front of you will change your behavior. Mm-hmm. Okay. And then they're claiming that if they put images in front of you in video games, it won't change your behavior. Right? Yeah. Now, at this point, my bells start to ring a little bit.
Yeah.
Right? But I agree that in general, I don't think we'd be in the mess we're in right now if people had the habit of being a little bit skeptical of, fake news that's flying around, of conspiracy videos on YouTube that have been pumped by Russian troll farms, of, I'm sure there are things I believe that simply aren't true, right? I'd like to think I'm a little better than I was 30 years ago about saying, okay, where did this belief come from and can I substantiate it? Right. And if I can't substantiate it, it's not that I should believe the opposite. It's that maybe I shouldn't have an opinion yet. Right? And the area I work in is software. So that's the place where I think I can push this idea of show me your evidence.
Right.
If I was working in healthcare, I'd probably be arguing against the nuts that tell you that vaccines are dangerous. I'm old enough to remember people in my hometown who were polio survivors. Right? Don't talk to me about vaccines being dangerous. I've seen the alternatives, but I don't work in healthcare. I work in software.
Right. I think it's interesting too that you talk about, and this is another reason why I think we need to be conversant on these things, as far as the numbers and the data and the statistics and how you actually analyze these things, is because you go on the general scale and you put these violent images in front of a 60-year-old, it may not have the same effect as it does on a 15-year-old. Or, you talk about software, it's like, well, if your team is made up this way, then maybe these practices work better than if these practices, than a team that's made up in a different way.
So another person you might find interesting to have on your show is Marian Petrie. She's a professor at the Open University, and she has spent 30 years studying expertise in software development. What does it mean to be an expert, and how do you get there? Right? She was one of the co-inventors of the cognitive dimensions framework that's still often used by people doing user experience design. And she said to me a few weeks ago that she can walk into a software company and tell you within seconds whether they're actually agile or actually waterfall.
What do you mean by actually?
What are they actually doing? Not what has management said, but what process are they actually following? And do you know how she can tell?
I'd love to know.
She looks at what's on the walls. If they are actually doing agile, then what's up on the walls and the notice boards and the whiteboards and so forth is their backlog. If they're actually doing waterfall, if they're actually doing design up front, what's on the walls is the architecture diagrams. And if they don't have either up, they're probably screwed. But I thought that was interesting that you don't ask management what process are you following, because then you're getting what somebody with an MBA heard in an airport and mandated, and everybody's like, yeah. We'll fill that in at the end of the week after we've got the work done. Right? If you want to know what people are actually doing, what do they want constant shared reminders of? Right? Now, is that a quantitative result?
No.
Don't think so. Is it a useful insight? Hell yes. Right? And she and her research partner have a book, I think it's called Software Design Decoded. Let me pull that up. Sorry for the typing noise in the background.
It's all good.
Just what they've done is, Software Design Decoded, 66 Ways Experts Think, by Marian Petrie and Andre van der Hoek. And what they've done is say, here are 66 patterns we've seen when experts are talking to experts about software design. Here are things they say and do and think that come up over and over again, so it's more than just chance. Right? Each one gets sort of a one-page description, and I think she should turn it into a deck of playing cards or something like that. So when you're in a design situation and you're stuck, shuffle a deck and pull out a couple of cards and say, okay, is this idea going to get us unstuck? Right. I also think that MIT Press should run off these pages as little frameable posters, and we can then decorate the walls of large software shops. And it's okay, this is what experts do. This is the toolbox they've got for thinking that I don't have. I've never considered myself an expert software designer. And again, I would bet the contents of my wallet, if I hadn't already done that, that it'll be a decade or two before this insight makes it into the standard undergraduate curriculum. Right. Before it's just common knowledge in the way that design patterns and object-oriented programming are now common knowledge. I mean, I don't have to explain what a visitor is or a singleton is. I just expect that somebody coding at my level knows those words. Right. And, I think that we'd be a lot further ahead if we spent a lot more time thinking and arguing about this stuff and left the sterile, vacuous debates about the relative merits of programming languages over to the side until we've got some bloody data.
Right. That makes a lot of sense. And I love the approach too. It's, well, I don't have enough data to support the conclusion, so let's go get some. How do we figure this out? How do we learn this? How do we prove it?
One of the things I remember from my time in Edinburgh was that juries in Scotland are unique in the English-speaking world in that they can return one of three verdicts: innocent, guilty, and not proven.
Oh, interesting.
Right? They can say neither side made its case. Right? Now, at this point, you've got a bit of a crisis because now the judge and the courts have to decide, do you get another whack at it? But, it's embarrassing for both sides to have a not proven verdict. Things like, you can think of a whole bunch of famous trials where at the end of the day, our system said you have to go either A or B. And the better answer would have been, we still don't know. Right? And I think that a Scottish verdict ought to be the default position of most people in the software industry.
Right.
So notice how I've managed to get away from any discussion of me.
It's all interesting, though. And I guess the other thing, I try and make people's journeys relatable. And I'm trying to decide, okay, so how do I make this approachable for people? How do I say, okay, if you're interested in what Greg's talking about, how do you do this without getting a PhD?
Oh, you don't need a PhD at all. Go and look at whatever project you're working on and build yourself a little dashboard to get a few summary statistics. For example, we know from study after study after study that regions of high churn in code are more likely to contain bugs.
Right.
Okay. I mean, one of the strongest predictors of is there a bug in this line is how often has that line been changed. Now, we can go and have a debate about cause and effect. Are the bugs there because you've made lots of changes, or are you making lots of changes because this is intrinsically a difficult part of the code? But I don't care. I want you to take a look at a heat map of how frequently each line has been changed or modified. And I want you to compare that to your test coverage. Okay. There was an interesting result from I think it was Les Hatton in the 1990s, who found that at least in scientific code, there's an inverse relationship between where the bugs actually are and which pieces of the code people test. And it's not because the tests are helping you remove the bugs. It's because we test the bits of code that are easy to test and understand. And instinctively, we steer away from those gnarly bits that are going to be really, really hard to test. So the bugs get left there. Right?
That's interesting.
Right? It's, we test the easy straight line cases because I can just knock that out in an afternoon. Right? But that bit over there, that asynchronous garbage collecting error handler that's going to throw an exception, but only on power down, that's never been tested. Right? Which piece of code do you think is more likely to actually contain a bug?
You've been looking at my JavaScript is what I feel like.
So taking a look, I mean, it's the work of an afternoon to go and mine your own Git history and say, okay, let's colorize lines according to how frequently they've been changed. There's a nice plugin for Atom or VS Code or pick your favorite tool.
Yep.
Right? And then you've probably, I hope, you've got test coverage data that'll tell you which lines of code are being executed by your tests. Okay. Put the two together. You just did some data science, right? You just did something actionable with data that you've got.
Yep.
All right. Pull up data for any medium-sized commercial project. Pull up data on the rate at which new bugs are being found and how long it is until the release. Like, you've got data historically. How many bugs were we finding each day in the run-up to this release?
Right.
Okay, so now you can build a very simple predictor model on that using, you don't need a PhD of any kind, right?
Yep.
And you can say, okay, given that model based on our own data, let's take a look at the project today. Oh, schedule says we're shipping next month. Data says it's going to be 3. Which one do I believe?
I love it.
Right? And yeah, it'll be wrong the first time, but as you get more data, you'll be able to tweak it and tune it. And I'm probably going to get this one wrong. I seem to remember work from Phone Switches Bell Labs back in the early 2000s where they were trying to see which one has more predictive value, the programmers or the code base. Like, people will move from project to project, right? But libraries will also get moved from project to project. Right. Okay? So if you track those and you look for contamination effects, is it the programmers who are sort of taking their patterns of work and you should be predicting based on who's on the project, or is it the code that's carrying all of its good points and bad points, and you should be using that in your predictors? And the answer is sometimes one and sometimes the other. Right. So, there's another really interesting result. And I'd love to dig in more. And I'd also like to do it for, 3-tier web applications and mobile apps rather than phone switches, because there aren't that many people writing phone switch software. But I'd really love to see, can we collect data from 10,000 React projects and put it together and see, oh, okay, here's one. If any of your readers want to be rich, famous, and popular, okay, are parts of React more difficult to use than others? I think so.
That seems likely.
Okay, so you don't need to be a rocket scientist to go off and look at the fixes made to correct bugs in React applications, and then say, okay, let's look at the functions being called. Let's look at the bits of React that are used in the code that has the most bugs, right?
Yep.
And maybe that ought to drive the design of the next version of React, is not what cool features can we add, but which things are people tripping over again and again. Let's get rid of those. Just down the street here in Toronto, a city crew 2 weeks ago was essentially grinding down a corner of a sidewalk because people kept tripping over it. It's a mobility problem. We've got some elderly people on the street, and somebody complained, and somebody came along and said, you know what? We're just going to make the bump go away so there's nothing to trip over. Right? That feels like engineering to me. That feels like a better world than the one we're living in. Right? And, people want to get involved in this kind of thing. They don't need an advanced degree in statistics. They need to know how to scrape data from GitHub.
It's so true. Well, and it's true in so many other parts of life too. It's okay, well, let's fix this problem, and then people throw out all these solutions, and it's well, what data do we actually have to support it? We have a number of people who are calling in saying that they're tripping over this particular sidewalk, and so we've gotten we've gotten enough of those complaints to make it worth sending somebody over there to grind the thing down.
Yep.
And, what do we see in our code? What do we see in our social problems? What do we see in our neighborhoods? What do we see in our, all of these? It's, okay, well, let's watch it. Let's measure it. And then let's make a decision on it.
Okay. Let me give you another beautiful one. Untitled Chapter and Neil Brown, who were at the University of Kent, and they're both now up at King's College in London, have a paper on 37 million failed compilations. Because there's a project called Black Box. And what they're doing is collecting data from high school students learning to program in Java in English schools, right? They get hundreds of thousands of events every single week. Every single failed compilation, they get the code and the failed compilation. They don't know what assignment kids are working on, but they can take a look at the code.
Right.
Okay. So 37 million failed compilation attempts is a hell of a nice database to analyze. So here's what they did. They went and spoke to, I think it was a couple hundred high school computer science teachers in England and said, what bugs do you think students trip over most often? What mistakes do they make most often?
Right.
There was no correlation between what the teachers thought was going wrong and what learners were actually getting wrong. There was also no improvement in predictive ability with teacher experience. You could be a 20-year classroom teacher and you still didn't know what was actually going wrong in your student's code. Because as a teacher, you only see the final result.
Right.
Right? So this has led me to think that the next programming language I'm going to get excited about is one that will have been designed based on that data. Mm-hmm. Here are the 10 things that people trip over most often. We're going to make them not be possible.
Right.
Okay. Gosh, doesn't that sound nicer than whatever you're programming in these days?
Yep.
Right? We're just going to make it not blow up.
Yep.
And we could go even further. I'm increasingly interested in the idea of TDD, which is tutorial-driven design. Mm-hmm. Okay? Don't design the programming language based on all the cool features you can add to handle concurrency. I want you, the first thing you write, not to be the tests, but the tutorial. Here's how we're going to teach this programming language. Here's how we're going to introduce the features one by one in a way that makes sense to people who haven't programmed before. And once we've written the tutorials, then we'll write the damn language.
Yep.
Right? Because if we can't teach it, what's the point of building it?
Yeah.
Right? That would require a bit of a shift in emphasis on the part of language designers, which I'm not expecting to see in my present lifetime or the next. Right?
Yeah, I don't know. I mean, it'd be interesting, but yeah, that's right? Not generally how we do things. So
it isn't, but I had the good fortune to work in a startup in the late 90s that was eventually acquired by HP. And there was an unofficial rule in the group that if the tech writer couldn't explain the feature, we weren't allowed to add it to the software. Mm-hmm. Right? We had to go back and redesign it.
Right.
Right? Because Annette would look at it and say, you know what? I'm sure you can build it. I'm sure it does what it wants, but I don't know how to explain to an overworked sysadmin how to actually configure that feature. Mm-hmm. It's just too hard, right? And I thought that was a really good gate for us to have to get through before we started implementation. In the same way that these days, I think in any mature software team, before you start implementing, you have somebody from QA look at it and say, no, I have no idea how we would set up the automated tests for that. Mm-hmm. Now, if you cannot create something untestable, so right. Go back and redesign it so that, decompose it, refactor it, give me extra API hooks, do something right. So that I can actually test this damn thing, because otherwise we all know what happens, right? So, I think that taking power out of the hands of the coders and giving it to all the other people involved in the production of software will make for better software, because it'll mean the coders have to meet a higher standard.
Yep, absolutely.
And I've still managed to avoid talking about myself very much.
Well, what are you working on these days?
I am working at a company called DataCamp, and we build online lessons in data science. I spent 7 years with an organization called Software Carpentry, running 2-day workshops to teach people in person. And by the end of that, I thought I had a pretty good handle on what you do live in front of an audience. Mm-hmm. Here's how, I think I know how to teach people, at least I think I know how to teach adults how to program. Kids are a different category. They've got different cognitive orientation, different teaching needs, but I know how to teach adults how to program. Working with DataCamp, I'm getting to learn how to get a computer to teach people how to program, because we've got 1.7 million registered users or something like that. And so all of our lessons are automated, and that's a very, very different medium. Mm-hmm. It's at least as great as the difference between a live performance and a studio recording.
Right.
And, I'm not old enough to remember this, but particularly in the 60s, a lot of artists began experimenting with what can I do in a recording studio that's just not possible live. Mm-hmm. I can play tapes backwards. I can sample. I can do, right. I can do Sgt. Pepper's Lonely Hearts Club Band, right? And I can do all of those experimental things that Glenn Gould was playing with, and I simply can't do that live.
Right.
Okay. I've already learned a lot about live teaching now that I've got something to compare it to. And the technology is fun, and it's fun to work with smart people who want to teach. Now, right now, we teach Python and R and SQL, and we teach machine learning and statistics and other things on top of those.
Right.
Those are the three main platforms. We've got other stuff in the works. We don't teach JavaScript at the moment because it's not widely used in data science.
Right.
If we do teach it, it will probably be for visualization. Mm-hmm. And D3 and Vega Lite and things like that are pretty compelling, but we're not there yet.
Very cool.
It is. It's fun.
Yeah.
It reminds me almost daily how rusty my programming skills are. At some point, I'm going to have to learn Docker because Docker is as important to technology today as HTTP was 20 years ago.
Right.
And, a decade before that, sockets. Right? There are things that come along and it's, everybody's going to use that as a basis for everything.
Yep.
And I don't know it.
Cool. Well, we're kind of getting toward the end of our time. Do you have some things you want to shout out about as picks? Do you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device, on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says pay me now. And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section.
Well, we opened with one of my favorite picks. The Bridge program in Toronto is, I think, a really good model that other companies could look at for a way you can actually move the needle on diversity and inclusivity. Uh-huh. Right? It works, and it doesn't require an enormous investment, and it makes a difference. And that's not a technology. It's just something that's making the world better.
Right.
On the coding side, as I said, somebody is going to take, Xtensor or the core NumPy libraries or something and wrap them up in JavaScript and have 100,000 users by December. And if anybody's interested in that, give me a shout. I have some ideas and I can talk about some failed attempts, but all the other pieces are in place. I'm working in bits and pieces on a short tutorial on JavaScript for people who are primarily doing research computing. They're analyzing and visualizing data. So they're not so much interested in frameworks like React and Angular. Mm-hmm. Really, for them, the whole point of JavaScript is the visualizations.
Right.
But the stuff you got to know in order to get there. And that's fun. It's partly a way to teach myself JavaScript, partly a way to create something useful. And then at some point, we're going to want to go back and revisit the Architecture of Open Source Applications books. Now, I don't know if your listeners will be familiar with those, but if you go to aosabook.org, we've got detailed descriptions of the architectures of 50 large open source applications and a bunch of other things on top of that. And they were all done in a mishmash of languages and in a mishmash of styles. At some point, I think it would be a lot of fun to go back and say, here's a small canonical implementation of a text editor in JavaScript. Here's a small implementation of a database. Here's the equivalent of a two-stroke engine. Everything real is an elaboration of these basic ideas.
Right.
Right? Because I certainly spilled out of undergraduate, not really understanding how the tools I was using were built. I don't know how to write a text editor. Right. I know how to use a text edit box in a web page, but I don't know what's going on under the hood. Is it one big string? Is it broken down? Just how does all of this work? And I think that an afternoon-length tutorial on that and an afternoon-length tutorial on how a document database works and how a web server works, and here's the baby version in a couple hundred lines of code, would be a really useful thing right now, partly so that developers will understand how all of this works, but partly also, I can't think of a better way to show off the capabilities of modern JavaScript than saying, here's my cover versions of the classics.
Right.
So haven't started on that, but, one of these days in my spare time.
Cool. Well, I'm going to shout out about a few things as well. This weekend was my wife's birthday, and so we took a trip. And anyway, I'm just going to shout out about some of the stuff we did. So we went down to St. George, Utah. I'm not sure if people are familiar with where that is. It's about an hour or so from Las Vegas. You drive up through the canyon in Arizona, and then you come out across the border in Utah, and that's where St. George is at. So it was warm, which is nice this time of year. And we always go to the Parade of Homes, which is, you just walk through brand new houses and see all their showpieces and stuff like that. And that's always a good time. So if you're ever considering a trip in February and you want to go look at, what people are doing with home building and style and things like that, I recommend that. It's just kind of a fun experience. Another thing that I'm going to pick, I signed up for a service that I used to do my traveling earlier in the month. Called Upside, and I used a promo code that got me some headphones, and they're over-the-ear headphones. They're Bluetooth, so they connect to my cell phone, but they connect, without wires, which is super nice. And they are the Bose SoundLink headphones, and they sound really good. I really like them, and those are the ones that I wear around now. So now I'm walking around with big honking black things on my head instead of little white things in my ear. But really like those. They compare pretty nicely to the Apple AirPods. I have a pair of those as well. The difference for me is that, if I wear my AirPods all the time, and I had the same problem with the earpods, eventually my ears start to get sore. And they tend to, it also triggers some earwax buildup in there. Putting headphones over my ears doesn't do that as much. It still does, but not as much. And they're much more comfortable. I can wear them for longer because they have the pads on them. So I really like those SoundLink headphones.
Well, if we're going to do a shout out for hardware, I've been really pleased. I've got a Samson Meteor as a microphone.
Uh-huh.
I used to be a Yeti guy. This thing is smaller. It's much more portable, folds up. It's very rugged, and the sound quality is excellent. So if people are looking for an $80 microphone for doing podcasting, conference calls, things like that, the Samson Meteor served me well. Would recommend.
Yeah, I tend to use the ATR 2100 when I travel. And that one's a $60 microphone. And that one looks a lot smaller and a little bit more, I can drop it on its head a few more times before it's going to die.
Well, one of the neat things about this one is the legs that make the stand all fold up to be a case around it. So it's one piece, and all the vulnerables are safely covered up. And I have had this one go down a flight of stairs and not a scratch on it. So
nice. I'll have to check it out. But yeah, there are a lot of great mics out there, and it's good to know that there's a smaller one like that. Yep. I had another one that was even smaller than that, and it just didn't work well. So yeah. Anyway. So Greg, if people want to see what you're working on or follow you on Twitter, or maybe you've got a blog somewhere, where's all the latest Greg stuff at? Sure.
I am GV Wilson on Twitter, and I am thirdbit.com in my personal life. That's third-bit.com, because I'm old enough that we actually made readable URLs instead of running all the words together. And it doesn't take more than one Google to turn up my email address, and I'm always happy to chat to people.
Awesome. Well, thanks for coming and talking to us. We'll get you lined up on some of those shows so we can go into depth on what we know and how we know it, and data science and all that stuff.
Well, honestly, if we're going to do that, go straight to the source. I would be happy to line you up with a couple or three people who are actually doing the work and get two or three of them on together to talk about this stuff. I'm a consumer of this research. I'm a consumer and I am a preacher, but I'm not the one doing this work.
Nice.
And, if you want to get Marian and Andre on your show to tell you what expertise actually looks like, I'm sure they would enjoy that. If you want to get some of the researchers who are actually studying how people build code on your show, sure, they'd love to talk to you as well.
That would be amazing. So, yeah. So, folks, keep an eye out. We'll line that up. Thanks for coming, Greg.
Always a pleasure.
All right, folks, we will wrap this up, and we will catch you all next week. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.